Welcome to the Colorlight course. This video will introduce you to how to use LED setting to configure data group swap and split style. In the first section, we will explain the concepts of the data groups. First, what is a data group? A data group is the signal source that controls the red, green, and blue LEDs on a module. These signals are generated from the receiving card and are transmitted to the module through the flat cables or signal adapter board. Taking the module with Hub 75 interface as an example, this interface allows input of two sets of data. According to the interface definition of the LED module, one set of RGB represents one data group. Second, why do we need to swap the data groups? The data groups from the receiving card are typically output in a specific order by default. For example, in the case of the 5A-75B receiving card, data groups are typically output sequentially from the interface J1 to J8. However, the physical location of modules may not follow the default order during the module installation. If the physical location sequence differs from the default order, the screen image will be chaotic. Therefore, it is necessary to adjust the output order of the data groups to match the physical location. In this way, we can ensure that the LED screen displays images correctly. Third, what is data group split style? Typically, there are limitations on the length of data group. Therefore, to avoid the display limitations and display quality degradation caused by overlong data group, we will use multiple data groups in the data transmission direction to control more pixels. This image shows the first way of module installation. In this way, the data for 16 modules is provided by 4 interfaces of the receiving card. Each set of 4 modules is cascaded together and jointly controlled by 2 sets of data groups from one interface. The approach of using only one column of data group to control the pixels in the data cascade direction is referred to as no split. In the second way, the data for 16 modules is provided by 8 interfaces of the receiving card. Each set of 2 modules is cascaded together and jointly controlled by 2 data groups from one interface. These modules are divided into 2 columns. The approach of using 2 columns of data groups to control the pixels in the data cascade direction is referred to as 2 splits. Additionally, if the data cascade direction of these 2 columns of modules is the same, this connection method is referred to as same direction 2 splits. Likewise, the data for 16 modules is provided by 16 interfaces of the receiving card. Each module is not cascaded with others and is controlled by a single interface. These modules are divided into 4 columns. The approach of using 4 columns of data groups to control the pixels in the data cascade direction is referred to as 4 splits. Similarly, other split styles follow the same principle. Colorlight's standard firmware supports up to 8 splits, and it should be noted that the number of pixels controlled by one data group should not exceed 8,192. If you need more splitting options and higher pixel capacity, please contact Colorlight's engineers. In the next section, we will explain how to use LED setting to configure data group swap and split style. Enter the software LED setting and select screen configuration. Password is 168 or 777. Then click Receiver Parameters to enter the settings interface. Check the module information and ensure it is correct. Otherwise, you will need to perform the intelligent settings again according to the last video course. Before data group swap, we need to complete the split style settings. First, confirm the way of splitting by checking the connection between the receiving card and the modules. For this cabinet, we could know it is 2 split, same direction. According to the definition of splitting, then we select the corresponding option on split style here. Next part, to restore the normal display from a chaotic image, we need to swap data groups. Click on Data Group Swap. Select Intelligent Mode and Reroute Groups. After that, the modules will display a white square indicating the position of each data group. Then click on each corresponding position in LE setting one by one. There's an additional situation to be noted. When the output interfaces of the receiving card are unused, the data from these ports won't display on the modules, so the corresponding positions on the screen won't show the white square during the data swapping operation. We could click Empty Group to skip these unused data groups until the white square appears. Finally, click Close to finish the data group swapping operation. The last step is to check if the LED screen is displaying normally. If so, then click Save to Receiver to prevent parameter loss in case of screen power outage. The data group settings course comes to an end. See you next time.